ओके। अरे आज थोड़ा नेट इशू था, नेट प्रॉब्लम था, यहाँ पे वाईफाई प्रॉब्लम है। You have the options. I can teach continuity for 10 minutes. After that, you can ask me any questions, or you can ask questions right now. You do have any questions? बताओ, बताओ, क्वेश्चन नहीं है कि पहले, just because continuity may need in the exam, I will just give you the definition of the continuity. Okay, I think you should read the page 100 and
101 and 102.
this you should read. But thing
Yes.
is that I said you have a function which should reflect on the metric. Look, y rho. Suppose you have a function. First of all, a map. I told you last time that it is a vehicle. Through that map, you travel from one space to another. That is the idea everywhere. In algebra, in linear algebra, here also, you should have a map traveling from one metric space xg to y rho. But how do you move? Because that should reflect on your metric. That means if you have the points are close enough, suppose x prime, then corresponding this point should be close enough. Now close enough, that's the big word that we'll have to quantify. Close enough, close enough is a vague word, so we'll have to quantify this. That will do. That how to quantify this close enough. Look, when you put in mathematical language, there is no confusion. Everybody will understand the same thing. But if you just put in the language, then different people may interpret differently. So that's why we'll have to quantify. But point is that if it is close here, it should be close here. That means if it is, suppose, delta close, that means less than delta, then it should be epsilon close. Now the thing is that way it will reflect the structure of the metric. Metric is nothing but you have the distance between the points. So that distance between the points it should be there. Because if there is an abrupt change, suppose you have small distance, but here you are getting big distance, that is when it is not reflecting, because I will prefer rho to be as good as D. That means it should be sort of its twin. Rho should be the twin of D, not something different entirely. Now the thing is that in the definition of continuity, now I come that you said delta close and now epsilon close. But the point is that first we go for epsilon close, then we find out delta close. You will see the reason why. Because here if I choose delta close, I do not know how much close they will be. Actually, my goal should be here that I should have mapped and how I will put a restriction how much this one is closed. Then I will find out how much this should be closed. That means given epsilon, first epsilon and then delta. Because epsilon gives you the freedom that how much you will choose them to be closed. And accordingly, you will choose the closeness of the points here. So first you get, don't forget, first you get epsilon, then delta. Now, so this is the idea, simple idea of the continuity. So the closed things should be closed, but how will you choose that closeness? Closeness will start from here, that how much close you want. That's the freedom you should have. Like close by half, close by 0.001, close by 0.1001, then you'll see how much is there. Now look, this way, first to recall the definition of continuity of a function, you got in the intervals, that is not a problem. Interval is also metric space. But look how you got the continuity at a point x. That means you got this, look, definition given. This is the definition I have given at the end of page 101. Okay, at the end of page 101, you see, look, given epsilon, that means any epsilon. This means any epsilon. There exists delta. That means it to denote that delta depends on epsilon. Delta depends on epsilon such that, look, what we got? That fx prime minus fx less than, that mod less than epsilon whenever x prime this distance less than delta. That means once you got it, x minus x prime this less than delta implies you got this. Delta is a function of epsilon. Now look, if I now change here the metric space xd and y rho, then what will happen? Suppose you have the metric space xd and here y rho. Now look here, problem was it's not a problem. Either the metric was the same thing on the domain and range. The metric are usually different, d and rho. So here you look, it will look like it is the domain. So dx prime x less than delta implies here the distance of the y. That means rho fx prime. Doesn't matter. Rho of x less than epsilon. That you should have. That means exactly, look, now erase this thing. ये ठीक है. This is your x. Suppose you have a function and you are taking a point at x belongs to x. This point you are picking at it, keeping it fixed, and then so that x prime will be the neighborhood on that. That I will explain. Given epsilon, that means any epsilon greater than 0, there exists usually write delta, but it should be understood delta will depend on epsilon such that this you have this. This is the definition. What you got for real value function on the real line, same thing. Okay, now look at this. This means actually what epsilon means. Look here, this epsilon means actually fx prime belongs to p fx ball, open ball centered at fx with radius. Here I am just writing rho to indicate this is ball in y. And this ball means what? The x prime, this belongs to this. That means x prime belongs to p t x delta. Okay, that means in the neighborhood term, if you do it, given epsilon means given any neighborhood of x, fx. Understand? There exists a neighborhood of this x such that, now look, it means what? Whenever you have it, you have this, that fx prime is there. That means f p t x delta. Okay, contained in b rho fx epsilon. That is the meaning. X prime is here, so fx prime will be here, and that is contained here. So this is the thing. That means the neighborhood terms ultimately you'll have to be comfortable in dealing with the neighborhoods. That means here I can write. Okay, let me write. That means what I will write. That okay, I will write. Look, this definition. F is said to be continuous at X if given any neighborhood or A neighborhood B rho, because neighborhood gives you the idea of the closeness. B rho Fx less than epsilon. There's the term is neighborhood. That exactly the thing, neighborhood. There exists a neighborhood B d x delta, a neighborhood, so the diameter need not be the same, but diameter would depend on this, because given x, fx is fixed. The only changing thing is that epsilon, whatever you choose. Neighborhood BD of x, actually, there exists a neighborhood B, here you should write, of fx. Neighborhood of x in xt actually, such that you have this. Look here, look what I was telling you, the idea of that. Neighborhood gives an idea of the closeness. That means you choose a neighborhood, I will get a neighborhood of x. So the entire image of that neighborhood will be contained in the neighborhood of x. That's the idea of what I was telling. Consistent, closeness. That means another way you can see that given a neighborhood of this f, I will get a neighborhood of x such that image of the entire neighborhood of x will be contained in this. Okay, right? So that they are not going outside that neighborhood. So this is the definition of continuity at x. Okay. So this will be enough. And if it happens, it is continuous at each point. If it happens, if second definition, if f is continuous at each x, at each point of x, you can say, at each point of x, then f is called continuous
on X.
On x, or simply when we just a whole thing x, sometimes we simply write f is continuous. When I say f is continuous, means f is continuous on whole x. And if you are just considering continuity at a point, then you'll have to say f is continuous at x. But if I don't say anything, just to say f is continuous, that means you are assuming that f is continuous on whole of x. Now, look that you can easily prove that by definition of using continuity only. Suppose f x t y rho is continuous. That is continuous at each point. Though ultimately you need a point on that. Now look, here you can prove if xn goes to x, that means a sequence converging in xt, then you have the image sequence, image point, then fxn converges to fx in y rho. That means under a continuous map, that's the first good thing. A convergent sequence is sent to a convergent sequence. Image of a convergent sequence is a convergent sequence. You just apply the definition. That means it is continuous at particularly it is continuous at x. समझ गया? You just apply the definition, you will see that. In fact, later on we will prove after the exam that converse is also true in case of metric space, that if it sends every convergent sequence to convergent sequences, then f has to be continuous. So it's a nice characterization of continuous functions on metric space. Again, a sequential characterization. So this one you can prove. Okay. But here you should, I'm leaving the proof to you. But here you may ask, what about Cauchy sequence? Suppose xn is Cauchy. I'm assuming f is continuous. In x t. Does it imply fxn is the sequence? Another bracket you need. Cauchy in while loop. Actually, you need something more than continuity. I am giving a counter example. Look here, this function f 0, 1. I am taking this usual distance to take x into 1 by x. Okay? This is a continuous that you did in undergraduate. समझ गया? But now look,
Yes.
1 by n belongs n greater than 1 you can take. Or you can take 1 by n plus 1. Sorry. That will be the better way to do it. Take the sequence 1 by n plus 1. Okay? This is Cauchy here in the domain. But its image will be what? N plus 1, this sequence, which is not Cauchy. समझ गया? Okay. So this is continuous. So something for Cauchy you need some better function than continuous. That I will discuss later on. But if you heard of uniform continuity and the function uniform continuity, then it is true. That will see that. We need to define uniform continuity between two matrix spaces. Later on we will do it. Okay. But I think if you already know the definition of the uniform continuity of a function where both domain are the range are subsets of the real line, then if it is uniformly continuous, then it will send Cauchy to Cauchy. Okay. But if it is not uniformly continuous, it may not happen. The example is this. Okay. Okay. So I think just now you go before the exam, I don't bother you much on that. So page 102, I have said close, suitable than that. Okay. Got it? That definition 19 prime that I gave in the term of the definition 19 and 19 prime. That I gave 19, the next definition in terms of the neighborhoods. Okay. So all these things are, I'm just working on only one definition. Definition 20 is that the whole space X. Okay. And I have given you example 1, 2, 3, 4. So it will be good enough. That is the thing I was theorem 6.11 page 105 that I'll do after the exam. So up to page 104 you should read. That will be part of your syllabus. Okay. Now let me tell you that what I should. I'm having an exam, the paper of the last year, having a, so that again I to tell you that what you should read first. First of all, okay, you should go for bounded sets, subsets of R. You should look that. How will you do it? You can take it A. That's the way you should study. You should study also methodically. It's not haphazardly ye padna hai, wo padna hai. We should figure out first. Basically, it's an algorithm of study. How you will start your study. So bounded subsets of R, you'll do it. Suppose A. Then you should look at the definition of sup A and inf A. Make sure you just understand definition. Okay, definitions. And here you should know working with sup A inf A, basically you need one consequence. What is that? That means if I take given epsilon greater than 0, there exists A epsilon. This A will depend on epsilon, belongs to A such that, now look here, we are having sup A, suppose. Sup A you can call it S1. And here, this is S minus epsilon. Okay. And you will get a point A epsilon such that S minus, first let me write it, A epsilon sup A. You tell me which way you can put this equality may happen. Which way?
A epsilon less than equal to sup A.
Be careful here. Be careful. Yes, that you remember that when I took this thing, A01 union 2. ठीक है ना? Here you can always choose less than epsilon, because you can work with s minus epsilon by 2. Even if that is equal, then it will be strictly less than s minus epsilon. So here on the left, it will be less than, and you can have it, but here it has to be less than equal to. Similarly, in phi, suppose in phi is t. In phi, given epsilon greater than 0, there exists b epsilon belongs to A such that you have, look, what will be diagram? This is in phi. It means t. This is t plus epsilon. Okay. So here some of that means you will get there exists b epsilon such that t. Sorry.
A.
I should have
Phi less than B epsilon.
ठीक है t एक मिनट t, that means in phi t less than equal to b epsilon less than t epsilon. Okay, here it may be less than equal to. Here you just change. Look here, if I do it, I will take -2. समझ गया? So that way you will see that. Here you can have less than it have, you need to have less than equal to because of this thing. But here you can afford. Okay, so these two things you must remember. I will give you a question on sup A in phi. You can ask your seniors in that at the last year's questions. Okay. So this I will give. Got it? Okay. So make sure that you need to do this. Okay, right? So in fact, on the real line, basically you need that much. Okay. And here already I said that. Now look at the come to the distance function that I told you that. Look how many, if you have a metric space xt, then you can take non-empty set. In the question paper, even if I forget to say non-empty, you can take non-empty. Okay. Now, first x belongs to x. Remember that, because I already told you why you need infimum supremum. Here it is defined in terms of infimum. Okay. All this part. That means this. You can write this way if you want. Look, if you want to work with this, you need to have that previous page. Previous page मैंने erase कर दिया क्या? नहीं, ये वाला. You remember, you need this thing. Okay, you need. Okay, so that this is very important. That's why I started with the infimum supremum. You will need that. Look, supremum will need when you consider diameter. Okay, right? So that this you need. And here one good thing is you should remember that Ax belongs to A bar if and only if Txa is 0. समझ गया? Okay. This here I think I have forgotten to tell you one thing. Suppose A is ठीक है, I will do. So make sure that you understand, and in order to do this, you can take sequential characterization of a closure point. Sequential characterization You don't need it, but you can do it without using this thing. Because if suppose X belongs to a bar, and if you want to show this, that means only you need it for all epsilon greater than 0. You need to show that this is this. Then obviously it has to be 0. That all need this way. That X belongs to a bar implies this thing. For all epsilon greater than 0, this thing. Other way it will be easier. Okay, that you need to prove in this. Okay, so that this is very important. This is very, very important. That you don't forget about this fellow. Okay, and then you remember that DAB we have defined. Again, you can have it in the step by step, or you can have this DAB. Okay, again distance between these two. Okay, right, but you should understand here it may happen that A intersection B is phi, then you don't expect DAB will be greater than 0. Then it is possible, but DAB is 0. It is possible. If you want to say that it is the pairwise, it is disjoint, and you want the distance greater than 0, that's an important thing in metric space. Then you need to put more conditions on there here. Okay. ये बताओ तो मुझे, give me a counter example for this. क्या है बताओ.
Discrete.
Actually, you can take this even 0, 1 in R, and A equal to this, and B equal to this. Got it? Look, they are disjoint because 1 is not here, open interval. But what will be the distance? Distance has to be 0, because ultimately you will be calculating distance from 1 to 1 itself, right? And in R square, you see, you draw this, so-called asymptotic. Remember that? Sorry. Asymptotic.
Yes, sir.
That will be this. Okay. Right? Okay. So that you should not have any misconception. If it is there disjoint, the distance will be 0. Still distance can be 0. Okay. If okay. Even though they are disjoint. But you can think of that if the disjoint is distance is strictly greater than 0, you need some conditions. Okay.
Closer non-empty होना चाहिए.
What were you saying?
Closer का intersection non-empty होना चाहिए.
Oh, you think if you have this, suppose, does it imply that DAB greater than 0? Do you think so?
Yes, sir.
Yes,
sir. मतलब दोनों का closer.
दोनों का क्लोजर. दोनों का क्लोजर तो आएगा ही.
Yes.
So first, yeah, that at least you got this. But is it necessary? This is the sufficient. Yeah. If you have this, दोनों का closer disjoint है, you must have it. Prove it. Okay. Got it. Actually, you can prove it. That basically you need this result. Sorry, X belongs to A bar if and only if dxa is 0. ठीक है ना? By using this, you can prove this. Okay. But if you think this is a necessary condition, is it a sufficient condition? You require that. Okay, think about it. It's good. Okay. A metric space में distance you need to know. I mean, functionality is very useful. Then I said last year a questions I put the boundary points, interior points and boundary points. Boundary, it is the boundary of A. So you should look at that. That I already discussed. Okay, Fine. Okay. And Cauchy sequence, I already just explained that. A continuous function sends convergent sequences to convergent sequences, but it may not send Cauchy sequences to Cauchy sequences. Okay. But point is that if you take complete metric space, then it, suppose, look, if you take this, if it is continuous, and if this is complete, look, my counter example I was taking incomplete. If you take complete, then if you take any Cauchy sequence, by the definition of completeness, that will be a convergent sequence. So that will be sent to convergent sequence, but every convergent sequence is Cauchy sequence. Okay. So if you want to have a counter example that Cauchy sequences are not sent to Cauchy sequences, you need this to be incomplete. Understand? Okay.
Yes.
That means if you like, particularly if you have this, that I proved by using Bolzano-Weierstrass theorem. If you have a continuous function on this, because this is complete, here a Cauchy sequences will be also sent to Cauchy sequence, because ultimately you are sending convergent sequences. So that for your counter example, you need incomplete matrix. That's why I was taking, remember that, 0, 1. This is incomplete. Samajh gaya? Okay. So if when you are looking for convergent sequence, make sure that, here I should tell you that. Okay, let me. A में supremum है, P में you should look at distance, right? You can between, right, non-empty sets. In a metric space. ठीक है? Okay. C, the sequence, the characterization of closure point, interior point, and boundary point in terms of distance. समझ गया? Okay. So this we got C. Now the part D में आएगा yes, completeness. That you should understand. It means every Cauchy sequence is convergent. So here you should understand the difference between convergent sequence and Cauchy sequence. ठीक है? This is very important to understand. I will give a question where you will be using completeness. Okay. Right. Got it. Completeness, convergent sequence, Cauchy sequence. Okay. So D. In last year's question, you should look at question 3 of the last year. Do you have the access to that question paper? Hello. Last year's minor paper. Do you have?
Yes, sir.
Yes, sir. We have.
Okay,
Yes,
then we should look at question 3. Okay. Question 3, let me explain geometrically what it means. Okay, let's go. Do you have? That question 3 में क्या किया? I was going question 1, 2, 4 ने मैं बता दिया. Now look here. We are looking at the plane. That means on the top of your laptop. Now look, or on your mobile, whatever you like. I said you take an integer n, natural number, positive and natural number. and take a equal to this. Those xy in r square in plane such that okay. Now look, I said this is always closed. Why it will be closed? Look, if you take m equal to 1, this will be a straight line, right? समझ गया? This will be x plus y equal to 1. समझ गया? Or y equal to 1 minus x. This will be a straight line. Of course, in fact, straight line is closed in r square. In fact, intuitively you can see that r square has dimension 2. So if you take a curve of one dimension, like line or like this, then it has to be closed in r square. Like hyperbola. God. Okay, see, this has to be closed. On the other hand, if you take m equal to 2, then you get unit circle. That is also closed. Okay, so you can see, but there is a difference. Similarly, m equal to 3, you can calculate, you can see that how it is coming. Okay, so point is that there is a difference in the. अरे कहाँ क्या हो गया? Right? Now look, even for m1, 2, both are closed each time. But you see that previously you got a straight line, which is unbounded. For m equal to 1 is unbounded. For m equal to 2, a is bounded. समझ गया?
Yes, sir.
m equal to 3 फिर भी करो, देखो m भी equal to 3 क्या आएगा? A will be unbounded. But m equal to 4, A is bounded. Okay. Now, but how to prove? That means what you are getting actually, that A is bounded, you can prove that A is bounded if and only if M is even.
Even.
Okay. That means the other word A is unbounded if and only if M is odd. समझ गया? Okay. Now the thing is that how to prove that? Here I should tell you the hints on that. Look here, usually you people say that if you have a polynomial of odd degree, then you say it has a real root, That you do. Remember that?
Yes, sir. Sir. Yes.
But be careful,
Yes,
the statement is actually wrong. Is what should be the correct statement? When you take this polynomial, it means your coefficients are real. Coefficients are real. समझ गया क्या बोल रहा हूँ? That means you should write a polynomial of odd degree with all real coefficients as a real root. Because if you take complex coefficients, then it need not hold. Then it may have all non-real complex roots. समझ गया? Okay.
Yes.
Got it?
Yes,
that
sir.
you should think about it. So here, when I prove that A is bounded if and only if M is even, or A is unbounded, okay, if and only if M is odd, M is odd, okay. Now look, if x to the power m plus y to the power m equal to 1, look, this equation y will depend on x, okay. So that means y to the power m equal to 1 minus x to the power m. So look at this polynomial. समझ गया? Got it? Now if m is odd, Look, if m is even, you can argue that if m is even, then x, y are real. So that this is a positive number, this is a positive number. समझ गया? So both will have to be. If m is even, then both will have to be less than equal to. That means look, when I say it is bounded in R square, it matlab kya hai? That means both x coordinate, y coordinate sets of x coordinates and y coordinates will have to be bounded, right? Okay. Other than it is unbounded means what? At least one set of coordinates, either x coordinate or y coordinate, will have to be unbounded. समझ गया? That look at that picture of R square. Now look, when m is even, then you are always getting. That means it will be inside this. That exactly you are getting in the circle and that. Okay, this is 1. Okay, this is minus. This is also 1. My diagram is a bit wrong. This is 1. So it has to be in between this. But m is odd. When m is odd, now look. Then how will I prove this is unbounded? Okay, ठीक है. तुम ये px है ना? ये you take a number, any number. Okay, c suppose. Then now you take this. Don't confuse it this p. Okay, right? So it will have a solution because x is real, so c is real. समझ गया? So it's a polynomial with real coefficients and m is odd, that you assume. So it will have the root, that means x, that means real root. समझ गया? If it has got a real root, okay, odd. Think of that. If you got a real root, then what happens? Okay. Then can I have this thing? When I will have this thing? Okay, let me write it a bit easier way. So let me write it a bit easier. Now suppose you choose any x, m is odd. Suppose m is odd, okay, and consider this polynomial. I don't need that. Okay, I don't need C now. Choose, consider this polynomial. This polynomial is a polynomial with real coefficients odd degree. ठीक है? Okay, that means there exists x prime in real such that one root x prime to the power m equal to px prime is 0, right? Got it?
Yes, sir.
Now what happens? Okay, look, you are getting this, fine. You are done. Why you are done? I'm telling you. That means x prime m equal to, this is 1. Now if I take y prime equal to 0, then what you are getting? Okay. I'm not going to the whole thing. I'm doing only part of this. That means this is a solution of that. This lies on A, right? Because I am getting this. Okay, right? Got it?
Yes, sir.
But you tell me there exists x prime, that if can I afford to have x prime arbitrarily large? Because x prime I am getting a root of this, but that root
No,
will
sir.
be what? That will be the same as x actually, right? That is same as x. Think about it. That means I can choose x arbitrarily large. Okay, if you don't like this argument, let me do this argument. Okay, so suppose you have is odd. Okay. Now look, I am taking this thing. Okay. Got it? C. Well, C take real. Got it? So it's the odd degree. So it has a real root. So that there exists x prime in R. This is important. In R. Such that Px prime is equal to 0, equal to 1 minus x prime to the power m minus c. Okay. Now, so that you are getting c equal to 1 minus x prime m. Okay. That means you are getting c plus got it? Now you think about this. This c I chose arbitrarily a real number. Okay. So I could choose some y, could change the car other than 0, such that you take c equal to y to the power n. Got it? Look, first I did for Jal C. Now I am saying, so I am free to choose any c. So choose any y greater than 0. Okay. And then you take m is given, but all choose c equal to y to the power n. That means now look, x prime y, you could take x also, that not necessarily x prime, same notation. This belongs to A. Okay. Got it? This is clear. Look,
Yes,
how
sir.
I am using that polynomial with real coefficients odd degree has a real root. Okay. If you don't have a real root, you can't do it. Okay. Now, so that means I will get, now look, because of this C I am taking this. So this I am getting this. Now look, so this belongs to A, but I could choose any Y. Because the big Y, it doesn't matter which number you give, I can always choose bigger than that. That means the set of Y coordinates won't be bounded. That means they will be unbounded. Got it? These I could choose arbitrarily large. So that A is not bounded. Got it? That's not clear. I think it should be clear.
No,
It's a very simple argument. I am using the fact.
Repeat.
बताओ.
sir, last argument didn't clear.
Last argument पहले C
Sir,
तुमने
how
समझा.
can we choose
ये
YR?
समझा तुम. Okay. First, if you want to have a good notation, you can see there exists R belongs to such that this. Oh, sorry. If you have problem with that. Okay. Or I could simply take that, let me see that. Instead of this, let me take this. Just take alpha. Alpha ठीक है. I'm just changing the notations on this so that you feel more comfortable. Now look, you are taking this polynomial, okay? Okay, this is, you are assuming m is odd, so it's the polynomial of odd degree with real coefficients. यहाँ पे तो ये 1 है, ये -1 coefficient है, -c है, ठीक है ना? Okay, so it will have a real root since it is an odd degree with real coefficient. So that exactly I'm doing, such that it is actually ठीक है. That means I will have this c equal to 1 minus alpha to the power n. Now this c, now we think about c, I got this. That means c plus this you got, right? Okay. Now look here, I didn't mention anything about c. I just chose a real number c. So now I'm saying for y coordinate, the alpha will be my x coordinate. I could take x coordinate also, it doesn't matter. So choose any y greater than 0, any y greater than 0. You can, if you don't like y, take beta here. ठीक है? Choose any beta greater than 0. So don't have the xy. Okay. And then choose c equal to beta to the power m. ठीक है? That means you will be getting by this thing. I didn't choose anything on the c. I just said real number. Now you are choosing, you choose any beta greater than 0. Doesn't matter. Arbitrarily large you can take. And then you take c equal to beta to the power n. It's a real number. So that here you are plugging, you are getting alpha to the power m plus beta to the power m equal to 1. Right? That means you are getting alpha beta. This point belongs to A. समझ गया? Now this beta greater than 0, I could choose any number. Any number. It doesn't matter big. Look, if it is to be bounded, if A is bounded, you should understand. If and only if there exists m greater than 0 such that for all xy belongs to A. That means, look, here when the R square we say the bounded means it will be inside a ball, but I could have other way that A will has to be bounded if it doesn't matter how big m, that means look like that. Inside a square it has to be, you'll be able to put it. Okay. Is it clear? This is your m.
Yes, sir.
So that exactly I'm doing. Now look, I'm saying, look, here alpha, beta, that is belongs to A, and beta greater than 0, but beta I can choose arbitrarily large. So I won't get any m. There does not, it means there does not exist m greater than 0 such that this less than equal to m for all beta. Because I could choose any beta and still alpha beta will belongs to m, A. So A will be bounded. That's it. Is it clear now? What is the problem? Batao. When it is in undergraduate, you didn't face this kind of argument. Look here, you think about it. It is very simple argument. I have
Clear.
chosen. All right.
Yes, sir.
Yes,
Yes,
sir.
sir, clear.
The bounded you
Yes,
are
sir.
doing, that's the diagram you look. I am basically doing right now in this thing. समझ गया? And if it's unbounded, it will go out. It doesn't matter how big M choose, it will go out of that. That square. Okay. You see, its size will be actually square of 2M side. Same M, 2M side. It will go out. So that this will be. In fact, let me tell you, this polynomial with real coefficients has a real root. You have used another place, and in fact, this semester you may need to use it. When you have finite dimensional linear operator, or you can take determinant or matrix A. Suppose you have a matrix A, real matrix you can take, but n by n real matrix. Okay. And if I say n is odd, then look, in eigenvalues of A usually will be all complex. They may not be real. समझ गया? They may not be real because your characteristic polynomial may come like this, x square plus 1, which doesn't have any real root, but it is the degree is 2. Then A has real eigenvalue. How to prove it? This is a simple thing.
Say x plus x
Its
to the
characteristic polynomial will have
Polynomial.
odd degree,
plus
and since
1.
I have taken real matrix, we will have all real coefficients. So that's the result you are using. So it will have a real root. That means it will have a real eigenvalue. समझ गया? So the same thing I am using here, but make sure real polynomial with real coefficients of odd degree, not only just say polynomial of odd degree. समझ गया? Okay. So the polynomial with real coefficients of odd degree has a real root. Got it? Okay. So try to understand this thing with example 3. That means with question number 3 of the last year, that means it will be bounded as well as closed if and only if M is even. समझ गया? Okay, it will be always closed. You can prove. We use sequential characterization of closure points, but make sure here I have given M. I have not didn't choose N, because if you go for sequence, then you'll be choosing N. So make sure you have different notations. Okay, I have given M, and you choosing the X. Basically, this is very simple. You'll have to choose let X belongs to A bar. So implies there exists a sequence. Okay, now the sequence will be here X belongs to A bar. तुमको नहीं लेना है. You are doing in R square ना. Then you should take a point like this, that XY belongs to A bar. So implies there exists a sequence Xn Yn. This is for the point bracket. There is another bracket for the sequence in A, such that, yes, right? But from here you will get what? Xn goes to X, Yn goes to Y. That from the distance follows, right? Because this distance means what? So this goes to 0 means this will have to go to 0. So this is goes to this. This will have to go to 0. This goes to 0. Okay. Then you'll have to show that you have this by using this. समझ गया क्या बोल रहा हूँ? Okay, right? That is easy because xn goes to x is the real number. So xn to the power m goes to x to the power m. Similarly, yn, you add them. ठीक है ना? But ये क्या है? ये तो सब a में है. That means each of them is 1, right? That you are getting a constant sequence. Got it? Okay, that constant sequence will converge to 1. That means it has to be 1. Got it? This is the proof. But make sure you understand the proof. This one I am telling you. I won't give in the exam, but you should look at the proof. So you know how to handle the A, how to understand A better. समझ गया? Okay. I will give something related problem to you, not this one that I am telling you. But you should look at the proof. I don't know what Bhavna will do tomorrow, but you should attend Bhavna's class tomorrow. But you should go there with your own queries to ask her. Okay, fine. So until now I have done what? Up to D I have given. Let me see then. क्या लिखा मैंने? A B C D, हाँ D हो गया, ठीक है ना? Cauchy sequence, convergent sequence वो भी बोल दिया. Just a few minutes. Now E, this is important. Remember, X is not a metric space. X is a non-empty set. And then we have taken, this is question number 5 in the last year's exam. Bx is what? Batao? I want to see you remember that. What is Bx?
Space of bounded functions.
Bounded
Yeah,
functions.
actually, it is a vector space of all bounded real valued functions on X, right? This is the linear space of all bounded real valued functions on X. And on this, you can give this metric big D. This is called the Subiman metric. This is defined as sup of
Mod fx minus jx.
that's right. X belongs to X. And remember that, look at the proof. This is important. That T is a complete metric. It is a complete metric means Bxt is a complete metric space. So look at the proof of that. Last year I gave the problem and I say that when you have X equal to R or C, it's not X equal to not R, sorry, X equal to N, then Bx is actually all real sequences. Okay, then this is all real sequences, all bounded real sequences. Then Pn, the set of all bounded real sequences. And I said that you could take the complex also, that doesn't matter. Bounded real sequences, and that case notation is L infinity. Some people write this, and here I said prove that it is not totally bounded. In fact, the way it is proved on that, think about that. If you take balls with, remember the definition of totally bounded. Here I should tell you that. You should remember the definition of totally bounded. Totally bounded. Okay. Remember that I did a result. This is stronger than boundedness. Stronger than boundedness. And remember that I did a result. Totally bounded implies separable. समझ गया? But a separable metric space need not be totally bounded. This is not true. Okay, right? Well, I have given not totally bounded, but still it may be separable or not. that you should look. That I think what I told you last time, I didn't give the proof. I gave the proof, I think. I was discussing the proof. That this is not separable also. समझ गया? Because no countable infinite set is dense here. That I told you that how to do that. Okay. So this is not separable. Make sure this L infinity particularly is very important. कितने स्टार लगाना है? 3 स्टार लगा दिया. ठीक है? Make sure that you read this very carefully. And last question 6 is again look bounded. It is all bounded, totally bounded, and relation between. And on R, you need Bolzano-Weierstrass theorem. The question 6, exactly what I was telling, gives you something relation between bounded and totally bounded. Okay, and question 7, you need basically Bolzano-Weierstrass theorem. Okay, so that you should do it. I think this is all right. I told you that. Okay, let me. क्या हुआ? ई में क्या लिखा मैंने? Bx लिखा. F में तुम ये लिखना है. It automatically will come. Totally bounded. If you go by this algorithm A B C D E F जो मैं लिखा, make sure that you read them. First try to understand the definition concepts and then look at the related regions. Totally bounded, remember that is a subset in a metric space is totally bounded if and only if every sequence has a Cauchy subsequence. Every sequence has a Cauchy subsequence, right? So remember that region. Of course, you'll have the note. You can always look. I did my PhD in the US. In the US, they always prefer higher level, particularly PhD level, open book exams. But the thumb rule is that in open book exam, if you open your book more than 5 times, book or books, whatever, that you are not going to do well in that exam. You think, oh, सब तो मेरा note पे मिल जाएगा, मैं note पे, then you are searching, note पे कहाँ है? You should understand. I already have taught you 100 pages. Okay? अब तुम 100 pages में ढूंढोगे, ये इधर है, उधर है. So that means first you should be familiar. कहाँ कौन सा चीज है? Okay? कहाँ क्या है? समझ गया? That you need to know clearly. That's why you need to read the notes carefully, and you go by this whatever I told you, that A B C D E F. ठीक है? और कुछ क्वेश्चन है? क्वेरी है? नहीं है? Hello. Then I will finish it. And tomorrow make sure you attend Bhavna's class. Even if you don't have any if you don't have anything to ask her, listen to what other students are asking and what she is answering. समझ गया? Just listen to what she is saying and what other students are asking. I am sure it's not, nobody will ask any question. Some students will ask question. So even if you are not prepared, you just listen to what other students are asking and what Bhavna is doing. समझ गया? ठीक है? So exam will be on Tuesday, September 28. I will send a message, but if I forget it, but you will have the question paper there. You will be sent. It will be in grade scope. Okay, it will be in grade scope. You will be sending that. I will send you the password and that to open the question. This is September. To 12 o'clock is fine, or do you want to take later? You can give me the time.
12 o'clock ठीक है.
Huh?
Yes sir, 12 o'clock.
12 noon. So by 1:45 p.m. you should submit it. And again I am telling you, whatever source you use, you should give me the reference. In case you do not have time, if you have forgotten, you can send me a separate email that I have used this source. समझ गया? You can send me a separate email. Okay. In case you forget or you didn't have time to all these sources, right? Then you can send me a separate email. Okay. So it will be 12 noon and end at that. That will be written there in the grade scope. ठीक है? Okay. Best of luck for your exams. Okay. See you. Bye.
Thank you, sir.
Thank you sir.
Thank you, sir.
Thank you, sir.
You are welcome.